10th CBSE Chemistry, Chapter Periodic Classification of Elements. In this video, you will learn the law of triads given by Dobereigner and also see the examples for the same, which includes the alkali metal group, the alkaline earth metal group, and also the halogen group. As the scientists discovered more and more elements, they also made an attempt to group them. Among the few who were successful, the first one was Johann Dobereigner. In the year 1829, a German chemist Dobereigner observed that certain elements had similar properties, and these properties were dependent on their atomic masses. So when the elements were arranged according to their increasing atomic weight, they formed a group of three elements which showed the similar properties. And because they were three in number, he called them as triads. The triad always had three elements A, B, C, for example. So according to the law of octaves, the atomic weight of the middle element in the group of triad is nearly same as the average atomic weight of the other two elements. The atomic weight of the middle element B will always be the average atomic mass of A and C. It is A plus C divided by 2, which gives you the value X, and this will be same as the atomic weight of B. This is what the law of triads stated. Now let us state the law of triads. The atomic weight of the middle element in a group of triad is nearly the same as average atomic weight of the other two elements. Now let us consider a few examples to understand this better. Now here is the first example, which is an alkali metal group. Now here are the elements which are listed: lithium, sodium and potassium. These are the three elements which form a triad. These are the symbols here of the same elements, and these are the atomic weights of the respective elements. Lithium has atomic weight of 7, sodium has 23 and potassium 39. Now let us examine if the group obeys the law of triads. So let us first take the first and the last element, that is the atomic weight of lithium, which is 7, plus the atomic weight of potassium, which is 39, and divide it by 2. So here we go. Here we have 46 and here 2. That gives us 23. Let us examine the atomic weight of sodium. Yes, it is 23. Now you can see that the alkali metal group obeys the law of triads. Alkaline earth metal group. Here we have calcium, strontium and barium in the group. Now observe here, the atomic mass of calcium is 40 and that of strontium is 88 and barium is 137. So it is 40 of calcium plus 137 of barium divided by 2. So it will be 177 divided by 2. That in turn will be 88.5. Observe the atomic mass of strontium. It is 88, which is very close to the average atomic mass of barium and calcium. It's not just the atomic weight which keeps these three elements together, but also their properties. Now, in this group, that is the alkaline earth metal group, all the three elements are metals: calcium, strontium and barium. And all the oxides of these metals are alkaline in nature. It means that when these metals form oxides, these oxides will be alkaline in nature. Alkaline means basic pH. pH more than 7. And all of them have valency 2. So these are some of the similar properties which the elements share. And the elements are called alkaline earth because the oxides are alkaline in nature and they are found in earth. So now let's move on to the next example, the halogen group. The halogen group has the elements chlorine, bromine and iodine with atomic mass 35.5, 80 and 127 respectively. Now let's examine the rule, that is 35.5 plus 127 divided by 2, that gives 162.5 divided by 2, which in turn gives 81.25 as the final answer. 81.25 is almost near to 80. So the halogen group 2 accepts the rule. Further, when we check out the properties of these elements, we see that all elements are nonmetals, all the three, chlorine, bromine and iodine, and all of them react with water to form acids. And further, they all have valency 1. These are the chemical properties which are common to all these three elements in the triad, that is in the halogen group. And the name halogen simply means salt producer, where halo is salt and gen is to produce. Halogens are the ones which produce salts. Halogens get their name because they produce salts when they react with metals. So now we have understood that the law of triads applies to the three examples which were given by Dobereigner. Though Dobereiner's attempts to classify elements based on their atomic mass and grouping them to form triads was successful to a certain extent, altogether it failed to arrange all the known elements in the form of triads. Not all the elements which were known at the time of Dobereiner fit into the triad system. Dobereiner could only identify 3 triads from the elements known at that time. So his classification of elements failed. Now let us recall few important points. The law of triads, which was given by Dobereiner, states that the atomic weight of the middle element in a group of triad is nearly same as average atomic weights of the other 2 elements. And the limitation of the law of triads was that it was applicable for only 3 triads. Other known elements couldn't be classified based on his law, which led to its failure. In this video, you understood the law of triads, saw the examples for the same, which included the alkali metal group, the alkaline earth metal group, and also the halogen group. We also understood the reason for the failure of the law of triads.